Everyone says acetone vapor smoothing ABS is easy. Just throw it in the container and wait. But how? With what setup? For how long? I tested a lot of Benchys to find out. Alright everyone, welcome to RunLit-Automation. Acetone vapor smoothing works by letting acetone vapor slowly melt the surface of your ABS print, just enough to melt together and eliminate layer lines. Done right, you get that glossy, almost injection molded finish you have seen online. When I started, every tutorial said the same thing: pour some acetone, wait a bit, done. But how much acetone? How long is a bit? Does it matter if you soak paper towels instead of pouring the acetone into the bottom? Or does a fan help? What about layer height? Does printing thinner actually change anything? Of course it does. Thinner layers smooth faster, but that also makes timing more critical. Too short and the surface stay matte. Too long and your print start to bulge, soften, lose detail, sometimes collapse entirely. No tutorials I found gave you the actual numbers. They all just said, check it every few minutes until it looks right. So I designed a proper test to get those numbers. Here is how I structured it. I split the testing into two parts. Test 1 answers the big question: which chamber setup actually works, and which one are waste of time. I'm comparing 4 chamber configurations across 2 layer heights, 0.2mm and 0.12mm. Here are 4 chamber setups. First, pour. Acetone pour directly into the container. Benchys sits inside. Second, wick. Acetone soak into paper towels lining both sides of walls. Third, pour plus fan. Same setup as setup 1, but with the fan circulating the air inside. 4. Wick plus fan. Same as setup 2, but with the fan added. Test 2. Take the winning chamber configuration from test 1 and sweep the exposure duration to find the sweet spot. Long enough to smooth properly, but not so long that details melt away. Yes, over smoothing is real, and I will show you what it looks like. Alright, let's go through everything you need before we start. 12-liter storage box. This is your smooth chamber. I grabbed one from Bunnings for $12. 2 88mm wide, 3 82mm long, 1 53mm tall. This could fit most of my smoothing need, from medium size to smaller. One universal box, that's it. One thing worth checking before you buy: look at how the lid sits on the container. Some boxes have really shallow grooves where the lid meets the rim. That loose fit lets acetone vapor escape pretty easily. You want a box where the lid groove has a decent depth and snug fit, even if you are not sealing it fully during the process. Don't tell me how do I find it out. Acetone, available at the most hardware stores. I grabbed mine from Bunnings. Check the datasheet and go for the pure acetone. Mine is greater than 99%. Avoid the diluted stuff. It won't work the same way. Measuring cup and funnel. I use this to keep my test consistent and quantifiable. Not strictly necessary, but you will also be surprised how little acetone you actually needed. So measuring helps avoid overdoing it. Kitchen paper towels. For the wick-based setups. 8 magnets. I will walk through how this works in a moment. Printed pin supports. These minimize the contact area between the support and your print. Less contact means fewer spots the vapor can't reach. Give you a more even finish overall. I printed mine in PETG. It holds up well against the acetone and is still pretty easy to print. Small fan. For the air circulation setups. Bench power supply with the alligator clips to power and control the fan. And of course, Benchy. Quick note on safety. Acetone films build up fast in an enclosed space and is flammable, so gloves and face masks are non-negotiable. Keep it ventilated, no ignition sources nearby, and a fire extinguisher if you can. Setting it up, use a funnel and measuring cup to pour acetone, and measured 30 ml for each Benchys test case. For the paper towels, here is how the magnet system works. Place the towel flat against the inside wall, then sandwich it with one magnet on the inside and the other one on the outside. They attract through the container wall and grip the towel in place. Then do the same thing again further down the same towel, so that 4 magnets per towel, 2 towels in total, 1 on each side of the wall. So 8 magnets all up. Simple once you see it. For setup with fan, the fan sits inside the chamber, powered by the Benchys power supply via the alligator clips. Variable voltage is handy here, so you are not just stuck on the full speed. Pop Benchys in, put on top of the printed pin supports, seal the lid, and we are good to go. Now let's compare smoothing results side by side. Because smoothing results are hard to quantify, so I designed a structured method to make the comparisons consistent. To evaluate each smoothing run, I used a standard scoring method across 5 surface zones on the Benchys: the bow, deck, bridge roof, and chimney. Each of these zones have different geometry, different orientations, and different exposure to the vapor, so they don't all smooth at the same rate. What looks great on the deck can look barely touched on the chimney. That variability is exactly what we are trying to capture. Each zone gets smoothness score from 1 to 5. 1 means no visible change from the baseline print. 3 or 4 is what we are generally aiming for. Mostly smooth, semi-gloss finish, with details still intact or minor loss. 5 means you are gone too far, sagging, denting, or even collapse. I also score uniformity separately, because a print can be technically smooth, but still uneven across surfaces. Glossy on the deck, barely touched on the chimney. All assessments were done 24 hours after smoothing. ABS stays soft for several hours, so scoring immediately will give you false results. 24 hours gives a stable, representative read. So the key findings from test 1. Fan is a critical variable. Whether you use a pull or wick, adding a fan roughly doubles the effective smoothing across most surfaces. Wick plus fan is the best method, achieving the highest scores across the most zones, especially on 0.12mm layer heights. Thinner layers respond better. 0.12mm prints tend to score equal or higher than the 0.2mm prints with the same method, likely because there is less mass per layer to dissolve before the surface smooths. The chimney is a structural blind spot. No delivery method can fix this easily. Now that we know the best method is wick plus fan, test 2 answers how long we should run. Same scoring scale as before. 3 and 4 are our targets. 5 is a danger zone. That means the surface has started to sag, dent, or lose structure. When you see a point spike all the way to the 5, that means a problem. So, what's a sweet time spot? For 0.2mm layer height, it's 45 to 60 minutes. Most surfaces plateau by then, and you haven't hit the over-smoothing threshold on any zone. For 0.12mm layer height, 30 minutes is a safe sweet spot. By 30 minutes, you have already achieved both 3, deck 4, and bridge 3. That's excellent results. Going beyond 45 minutes risks the bowl damage on these thin layers. 2 observations that hold true regardless of time. First, the chimney never changes. It stays at 1 across all 10 configurations. Vapor simply can't reach. Second, the bridge roof plateaus at 2. The top slope geometry means the vapor can't do effectively as flat surfaces. Bringing both tests together, the best overall result in the entire experiment was wick plus fan. 30 minutes, 0.12mm layer height. Mostly smooth, semi-gloss, details intact. Or fully gloss, minor detail loss, with glossy but still noticeable difference in the uniformity. That mainly because hard to smooth the slope roof area and the chimney. But overall, it's well distributed smoothing without any structural damage. If you are printing at 0.2mm layer height, extend at least 45 to 60 minutes, but watch the bowl closely. And no matter what you do, the chimney will need a different approach entirely. No fan? Just extend the time. Wick alone at 60 minutes will get your deck at mostly smooth or full gloss, and partial improvement on the bridge. The bowl most likely have visible layer lines. A smaller dedicated chamber is more suitable for the print. Although for a bigger or universal box, without fan is not as efficient, but it's still acceptable for surfaces that face upwards. Just don't expect the same uniformity without a dedicated box. And keep in mind, the chimney and bridge roof has no limitations, which will not truly diminish the layer lines. Extra findings. 4 things worth knowing. First, weight. Almost every Benchy came out at 9 grams. Same as before smoothing. It's essentially unchanged. So this process isn't removing the material, it's redistributing the surface layer. What actually matters is vapor saturation and how well it reaches the print, not how much the acetone you pour in. Second, acetone consumption is surprisingly low. After every session, there was still plenty of liquid left in the container. 30 ml was more than enough for this Benchy test. For your own print. Basically, as long as you can saturate the air inside your chamber, you have enough. Third, without fan is okay. Wick only gets you surprisingly close to the fan result. Just add around 15 minutes to the recommended time, and check periodically until you are in the right range. Fourth, and this one is important, don't trust what you see inside the chamber while it is running. What looks like a full gloss inside the box may end up over-smoothed once you take it out. That's because acetone gets trapped inside the ABS. It will continue smoothing itself as the acetone slowly evaporates and settle where you actually want it. Quick recap. Wick plus fan, 30 minutes, 0.12mm layer height. That's your best starting point. No fan? No worries. At least 15 minutes. Going longer? Watch the bowl. And pull the part out slightly before it looks done. It will keep smoothing itself after. There is a lot more detail that's hard to cover in a video. The full write-up is linked in the description, so check it out if you want to dig it deeper. Don't forget to link and subscribe. Thanks for watching, and I will see you in the next one.